Okay, we're going to start with the first 2 pages of the concentrating on concentration handout. I'm going to briefly go over different units for concentration, because as we move through these problems, most of them will be dealing with the fact that there are amounts of solute dissolved in a solvent. A reminder, solute is what's dissolved into the solvent, and we'll be basically either quantifying how much we have in a solution, how much we need to make a solution, or how to convert in between different units for the same solution. Molarity is the most commonly used form of concentration in chem, and it will always be the number of moles per liter of solution. Since we can't weigh out a number of moles, we're going to be using the tool of molar mass, which are these numbers on your periodic table. They are always how much something weighs when in the units of grams per mole. And mole is just when you have Avogadro's number worth of them. It's just how much it weighs when you have just a crazy amount of them. And we need that crazy amount because atoms are so small. So molarity will be going number of moles of solute over liter of solution. Remember, solution is equal to the solute plus the solvent. In general chem, I usually say total solution to remind you of that. So we'll be able to, we need to be careful as we go through calculations if we're talking about the solute or the total solution. Notice all units for solutions chemistry will be per solution, per total moles, which would be total moles of solution, over solution, except for molality, where we just talk about the solvent. So real quick, mole fraction is the number of moles per total moles. So here we'll need to find the moles of solute over, if we're given moles of solvent, we need to add it to the moles of solute to get the total solution. This is just total moles no matter what, and we'll use this way down the road. Percent composition can vary. I'll try to be explicit about asking if it's a mass over mass percent, whatever units I give you. I'll try to be explicit on which ones you need to report your final answer to. Percent, the most important thing here is, not always, but most often you'll be get an answer like 0.0092. And you can't report that as an answer. You need to convert it into a percentage. So you'll say 0.92%. And we'll always know that percent is per 100. So that just means you've if you've divided by 100, by adding this percent sign, you need to multiply this number by 100 to make it the same number. Okay, parts per million. This is an important one before we move on. Parts per million could be any percent composition where you most often would elicit a very tiny number, and instead of it multiplying it by 100 as we do for percent and adding a percentage sign, we will now multiply that number by 1,000,000 and then add the units ppm. Very commonly, you will see parts per million expressed with the units milligrams per liter. And since most often we'll be talking about this total solution being in a volume of water, the amount of a liter of water at 4 degrees Celsius and 1 atm weighs 1 gram per milliliter. So we're able to do the conversions, and you'll see this is basically integrating parts per million into the units. Just like you can have 1 second per 11.5 days, 1 inch in 16 miles. Those units are already telling you that we're talking about one whatever the number is expressed per million of equal units. Since these units aren't equal, these are taking care of the 6 places of a decimal point. And we can move on to parts per billion. It's the exact same thing, so I won't go into that much. We just go ppb, and then it would be something to the effect of a microgram per liter of water. And then molality, we have moles of solute per kilograms of solvent. And this is most often used in colligative properties, which we'll get to later. So we'll do this first 3 problems, do the next 3 problems, and hopefully we won't have a problem doing the problems. Okay, what is the mass volume percent? And then I put M over M percent, which is already giving you an issue here. So let's just put mass per volume percent, my bad, of a solution that has 23 grams of sodium carbonate dissolved into a solvent, creating a final volume of 500 liters. Now, lots of times the fact that it's sodium carbonate would be important, but here it is not, because I'm asking you to leave it in grams, and I'm giving you grams, and I'm giving you a final volume of. Final volume of is another way to say the total solution. So here I'm giving you grams of solute per total solution. What is the mass per volume percent? The only thing we're going to have to do is when we get an answer in our calculator is do the correct sig figs, the units, and make sure that we express it in a percentage and don't leave it as a number without doing so. So the mass per volume percent is equal to the mass of the sodium carbonate, which is 23 grams per 500.0 liters of solution. We're just going to put it in the calculator now. 23 divided by 500. Oops. Oh, great. 23 divided by 500. We get 0.046. We need to report the correct number of sig figs. As you see here, we have 2 sig figs. We have 4 sig figs. When doing division, we can only report the lowest number of sig figs. So right now we have 0.046. We need to express that as a percentage. If we put the percentage sign, that means that percentage sign means divided by 100. So we need to take this number and multiply by 100. Your previous teaching in math probably just says move the decimal point over 2 places. But the reasoning behind is what I just stated. So we'll go 4.6% MV that'll be sufficient. Okay, here we go to the next one. And mix a solution by adding 83 grams of sodium hydroxide to 750 grams of water. What is the percent by mass, mass over mass percent, sodium hydroxide in the solution? And I say careful. Hint, hint. We're looking for a mass over mass percent, and we have grams of sodium hydroxide. So we have grams of our solute, and then I give you grams of water. Notice grams of water is not your solution. Grams of water is just your solute. When we express any concentration other than molality, we need the solute over the solution. And another way to state this is solute over solute plus solvent. So here we need to take the 83 grams of sodium hydroxide and put it over the 83 grams of sodium hydroxide plus the 750 grams of H2O. We will talk in great depths, if you didn't have me for general chem, about addition and subtraction sig figs, because some things can change there, and if you've already had AP Physics, you know this, but we'll go over that for a day after class begins. So we have 83. I'll just do it, and we'll learn it later. Plus 750, 833. I'm very comfortable with my calendar or calculator, so I like to just whatever number's already in my calculator work from that point. So I often hit divided by 83 and then flip over the answer. Don't do that if you don't like it. Just figure this out and then divide. Well, we can just do this. I'm going to do it my way. Flip it over. You should get 0.099639. Yeah, way too many sig figs. We have 2 here. When you do the addition here, you actually will generate 3. We're still limited by 2 in either manner. And we need to put that in a percent. So I'm just going to do it from here because I think y'all are smart enough to. We'll go, well, this one's a little pain in the butt, so I'll write it out. We have 0.0996. We need to put that into a percent. So I'm going to multiply it by 100 and then divide it by 100 with my symbol. So I keep the same number, 9.96%. And this is not okay either because you know we only need 2 sig figs. And this will round that up to a 0. And a 10, right? So this will end with 10 point. Another way of writing this, more common way would be 1.0 times 10 to the first, but good Lord, this is enough. So 10% NaOH. And text will vary. I think it's important to say gram over gram or M over M is less information but also used. So mass over mass probably. And we're done with that one. Next one. What is the volume over volume percentage of a solution that has methanol dissolved into water? This is same as the next, or same as the last one. So I'll go faster. Here we have our volume of solute. Here we have our volume of solvent. We can't just divide the two. We need to find the solution. And then we'll put it, they're both already in volumes. We don't need to do a conversion for density. Don't need to go from grams to moles. We just do this and make sure we report 3 sig figs this time. It's looking like. Calculator. Let's see what our calculator is going to give us for this one. 205 divided by 705. And we get a 29%, nice clean number, or no, we need 3 significant figures this time. So we're going to say 0.2907. We need 3. So this matters. We'll get 29.1% methanol. You may